Have you ever really looked at a word, and even though you can see it, it's right there in front of you, it still takes a second for your brain to get what it means.
It's a weird little delay, isn't it?
It is, and it gets even weirder when you realize that this tiny quirk of consciousness, this mini mental pause, could be a key part of recreating consciousness artificially.
Yeah, and the exciting part is that we're not talking about actually building a physical brain here. That's a whole other can of worms. This is about understanding the software of consciousness, the core principles, the how, and whether we can actually code that.
And that brings us to the work of Lenor and Manuel Blum, two real pioneers in computer science. They've dedicated themselves to creating a computational model of consciousness, which is dot ambitious, to say the least.
It really forces you to think about, like, what awareness actually is.
Well,
Could an algorithm really experience the world the way we do? It's a huge question.
absolutely. And to even begin to wrap our heads around their model, what they call the Conscious Turing Machine, or CTM for short, we've got to start with this idea of a theater in our minds. Picture a stage, right? That's where your conscious thoughts, the stuff you're actively focusing on, comes to life.
It's like a spotlight, zeroing in on the most important information and leaving everything else in the dark.
Right. And just off stage, you've got all these actors hustling around. Each one of them is a thought, a memory, a sensory input, just waiting for their chance to grab your attention. But there's another part of this theater we can't forget. Way up high, in the balcony.
You've got the audience. They're the long-term memory, watching the whole show of consciousness unfold.
And this theater model is more than just a cool visual. The Blums use a really relatable example to explain how it works. That moment when you blank on someone's name at a party. We've all been there.
Oh, tell me about it. It's like, you know them, but their name is just gone. So frustrating.
The worst. But then later on, maybe when you're driving home, the name just pops into your head seemingly out of nowhere.
And it's like magic. That aha moment is your mental audience, your long-term memory, finally finding the information and sending it to center stage. It's a perfect example of how these different levels of consciousness work together.
Okay, so we've got this mental theater, right? But it's not exactly a peaceful, contemplative environment.
Oh no, not at all. It's more like a constant battle royale for our attention.
Like those cooking competition shows, but for our thought.
Exactly. Every single thought, every little bit of sensory information coming in, every memory that bubbles up, it's all fighting for a chance to be in the spotlight of our awareness.
So our brains are basically stuck playing referee 24/7.
That's a great way to put it. And the CTM tries to model this whole chaotic process using, of all things, a tennis tournament.
A tennis tournament. Okay. I'm intrigued, but also kind of terrified. Are my thoughts about to get tennis elbows?
Not quite, but I love the image. Imagine this. Every single thought that pops into your head, every idea, every memory, every fleeting impression, they're all players in a massive tennis tournament, vying for that championship trophy.
And that trophy is dot conscious awareness.
You got it. The thing is, just like in a real tournament, not all players are created equal. Some thoughts are just naturally more important or urgent than others, right? So they get ranked accordingly.
So a really pressing thought like, oh, shoot, I'm late for that thing, that's got to be like a top-seeded player, right?
Exactly. High ranking, definitely going far in the tournament. But then you might have a random, less urgent thought, like, I wonder what my dog's doing right now. That one's going to be ranked lower, more like a wild card entry.
So does that mean the little thoughts never stand a chance? It sounds kind of brutal in there.
Well, the CTM says that even the low-ranked thoughts have a shot, and it all comes down to probability.
Hold up, probability. Like a random number generator deciding which thoughts win.
In a way, yeah. It's kind of counterintuitive, but the Blums found that where a thought originates in the brain doesn't really matter as much as they'd initially thought. It's more like each thought, regardless of its ranking, has a certain chance of winning each match based on probability.
So my brain's basically running a lottery for my thoughts.
You could say that. It's like flipping a coin. Sometimes the underdog comes out on top, even if just for a fleeting moment of our attention.
Wild. So this CTM is doing a pretty impressive job of mirroring how our minds prioritize information, but it also has to learn and, actually interact with the world outside our heads.
That's where chunks come in, right? This is where it gets really interesting for me.
It is. Chunks are like the fundamental building blocks of understanding that the CTM uses. Think about a newborn baby. They don't know much of anything.
Right. Bless their hearts, they're just figuring things out.
Exactly. They learn through trial and error. Let's say a baby cries, and then, what do you know, someone feeds them or changes their diaper. They start to associate that action, crying, with getting your needs met. So, like, crying equals oxygen. That's a pretty essential chunk of knowledge right there.
Literally. And the CTM works in a similar way. It starts with a super basic understanding of the world, and then through constantly trying things out, getting feedback, and updating its knowledge base, it builds up this incredibly complex model.
So it's constantly learning, just like that baby.
Totally. Always adapting, always refining its understanding based on the feedback it gets. It's a loop, constantly evolving.
So we've got this model that can seemingly mimic how our minds prioritize thoughts, how it learns, how it interacts with the world. But can it feel? Can an algorithm really experience the joy of, like, finally getting that wordle or the frustration of hitting every red light on your commute? That's the million-dollar question, right? Can we program feelings? The Blums model seems to nail how a machine might think, learn, react. But experiencing emotions, feeling that ouch when you stub your toe, that's different.
It's the core of what's called the hard problem of consciousness. We're kind of okay with replicating cognitive stuff, the thinking part, what the Blums call cognitive consciousness.
But that deep down feeling, your own internal world, their phenomenal consciousness, that's the real head scratcher.
And, to their credit, the Blums admit they haven't cracked the code on feelings yet. As amazing as their model is, it doesn't quite get to that inner experience.
Which, is a relief in some ways, right? No sentient AI taking over the world just yet. But even if we don't have all the answers, this whole CTM thing makes you wonder. What if consciousness really is just a super complex algorithm deep down? What does that even mean for us as humans?
Right. It makes you question what makes us special. And, it's interesting, the Blums themselves have different takes on this. Manuel seems to think AI could eventually outstrip us intelligence-wise, like it's only a matter of time.
While Lenor sees it more as a team effort, humans and AI working together, kind of like combining our strengths to create something even better.
A partnership, almost. Definitely a future full of potential no matter how you slice it. But yeah, whether a machine can truly think and feel, that's still a huge question. The Bloom's work gives us a really solid starting point, but like all good science, it raises even more questions than it answers.
And that's the beauty of these deep dives, isn't it? It's not about finding all the answers neatly tied up in a bow. It's about sparking that curiosity, making us look at things in a new light. We might not know for sure about consciousness, artificial or otherwise, but just thinking about these things, that's a big part of what makes us human.
Totally. It's a journey, this whole understanding ourselves, our minds, how it all works, and the discoveries we make along the way, they're just as important as any destination.
Couldn't have said it better myself. Well, folks, we'll leave you with that thought. Until next time, keep exploring, keep asking those big questions because this universe of knowledge we're in, it's pretty amazing.